Hello, everybody. Welcome to our panel discussion on contributing to the numerical package community. We are here today with a great group of panelists, some of whom you've already met in the morning sessions, I think. Anne Almgren is here for AMREX, Aaron Fisher for MFEM, Christian Glusa for MILU, Richard Mills is for PETSI, Dan Reynolds for Sundials, and Cameron Smith for PUMI. I will start the session off with a question that I think is essential to cover, and then we'll move on to submitted questions. And in the meantime, please write your questions in the Track 5 numerical Slack channel, and I will call upon you to unmute and ask your questions in the order that they're posted. So to get the ball rolling, maybe we should start with, so how can users and outside collaborators contribute to your software packages, and what software development practices are essential when contributing?
So I can start with that, I guess. I'm here representing the MFEM package. Our package is on GitHub. We actually have a developer's guide that you can take a look at if you wanted to add something. But really the first thing you want to do if you want to contribute is kind of get your head around what's there. And we use the GitHub issues, so you can communicate with the developers on the GitHub issues. And then some of the easiest stuff to sort of get into is documentation, testing. Those are some low-hanging fruit to kind of wet your whistle. If you you have more sophisticated things you want to add, we accept pull requests, and we will guide you through that process.
I think I want to echo what Aaron said. Get your head around it is the starting point, and keep in mind that the functionality, you may have a need for a very specific functionality. When you submit a pull request and ask for it to be part of that package, if the developers accept it, they are accepting the responsibility to maintain it. And so when you think about their perspective, they would love to have you contribute. They would absolutely, I mean, we don't want to have to write all the software in the world. We would love to have you do that. The problem is if you submit something that we can't maintain, it's a lose in the long run. And so it's very much a relationship that you need to understand where we're coming from. We need to understand what you want. And it's not a one and done. If somebody shows up and just submits a pull request, we don't know who you are. We don't know what the motivation is. If it's perfect code, then great. But a lot of times it's an iterative process. And so I think the message is we absolutely welcome it, but understand that the developers are taking on a responsibility every time they accept code into the repo, because we don't want to have broken code out there. So we're taking a responsibility to maintain it. That said, we want you to contribute.
Yeah, you really kind of have to become part of the developer community a little bit, right? So in addition, on the MFEM team, we've got maybe 20 kind of core developers, but in addition, we've got 150 people online that are kind of talking about the code and doing little changes and asking questions. If you become part of that ecosystem, you'll understand what's going on there.
Yeah, and kind of to the point where both Anne and Aaron we're talking. Every package there's a kind of a style that is pretty much used throughout the code, and if you write something that looks completely different, it's hard for them to maintain. It's hard for other people to read. So I'd say read the code as well. Just see what's there and how it's written, how they kind of try to do error handling and checking for weird corner cases, because some users don't call things the way that anybody anticipated. But try to get yourself in the mindset of the people who wrote it originally, and then when you want to add something, it's easier for it to be reviewed. It's easier for everyone else to be a part of it, and easier for you to become part of the team.
And echoing something Aaron said, starting with documentation is a great way to get your foot in the door. We love to have people realize the documentation is inadequate and fix it. And the other thing, for example, with the AMRX project, we've actually separated out. We have an AMRX tutorials GitHub, and that is an easier place to contribute because you can have a more specialized example. And it's a good starting point. If you have something, here's the functionality I did, I'm going to put it locally. It's an easier place to start.
Yeah, it helps us a lot to have people that are new at the packages contribute documentation, because we've got this, we're steeped in this. We forget the things that people don't know when they first come to looking at this. So it really helps to have fresh eyes on that stuff. And once you kind of get your head around it, building some documentation around it it helps a lot.
I mean, I would add to that to also ask questions. I mean, we know our software and we can help you if there's a functionality that you want to add. We can either tell you, oh, this functionality is already in our software in some other form, or this would be a great addition. Would you be willing to actually do this for us? Because I mean, there's so many things we want to do, but we don't have the time to do it. And if somebody comes along, hell yeah, I mean, we want that.
So I think actually, sorry, go ahead.
I was just going to say, you know, from my perspective as a longtime Petsy user and developer, I think in the Petsy community, very little of the development or new features are kind of like driven, top down by some kind of like DOE programmatic need. A lot of what goes into Petsy just kind of happens organically by users really getting familiar with Petsy and identifying needs that they have that Petsy can't meet, but might be able to meet with a little bit of stuff added to it. Or also people identifying needs through the really very active discussion forums between the users and developers. So echoing what some other people said, kind of like making sure to integrate yourself into that community of the people really using and developing and talking about Petsy and really trying to use it for your own problems is a great way to identify a way that you can meet some need that hasn't been met yet.
I think very much related to this, actually, we got one question that I think would be a good follow-up submitted by Stephen Wood. If you'd like to unmute and ask, please go ahead. Maybe we can unmute you here. Do we have a host or co-host who could? Oh, there we go.
Trying to unmute now. Can you hear me?
Yeah.
Yeah. I was just I think that the term open source has been really oversubscribed, and the consequence of that, I've seen some packages not be adopted because there was a fear that we don't know the lineage of that software. We don't know who contributed to it. And in other cases, open source simply means that it's available to the public. How can we better distinguish between contribution to software and its distribution?
So yeah, I agree. It's a bit of an overloaded term. All of our software packages, are out on GitHub, and they come with the associated licenses. MFEM in particular is under the BSD license. And when it comes with rules as to what the contributions, what happens to the contributions and what license those are under. So everything that gets contributed to MFEM is licensed under the BSD license. And the terms and conditions that come with that. It's a very easy to use license. In the past, some of the GPL licenses have kind of been stumbling blocks to, like, for instance, companies using our open source software. So I think most of us are migrating away from those kinds of licenses and more into the more open and easy to incorporate licenses. Did that answer your question?
Yeah, but I'm wondering if we need a term that differentiates who contributes it, what kind of gatekeeping is involved, separate from whether it's publicly available for free and the licensing and reuse policies for software.
Well,
So-
I mean, some people talk about, community software versus just open source software. I'd say, like, everything that's really like a community supported piece of software is an open source piece of software. But there's also a lot of stuff where a user community has very little or no input into it, and some development basically happens behind closed doors, and once in a while they do a source drop, and so it's open source in that respect. So I would distinguish between sort of like community software versus just the open source label. I mean, that's one way I think about it. I'm sure there others can add to ways they classify these things.
Yeah, one name given to the first of those two categories is open development, where you can see what they're coding out in the open. You can see what they plan to pull in. You can see all the bugs they introduce as they're, almost as they're typing them. Whereas, open source could additionally mean the second one Richard said, where, people develop in their own repositories, their private repositories or whatever, and then they push, released versions out to GitHub that are free. And so maybe the open development versus open source it helps differentiate those. But I feel like the question was kind of hinting at how does a user know the quality of something? And I don't know if there's any simple way to answer that question.
Yeah,
Well,
I think, oh, go ahead, sorry, please.
In some sense, so everybody here today presenting takes pride in their software. So there's a set of software where there are people's names and reputations behind it. There's, in some sense, I think it's a small enough community that there's certain software you come to know. A lot of the software has been around for a while and you sort of know some of the people behind it. Yeah, if I saw a software package that looked really good and all I saw was a GitHub address and I didn't know, I'm not sure a label would fix that. I think there has to be kind of a get to know you process. Yeah, I think it's too gray an area to be able to put a label on. Is that kind of what you're asking, Stephen?
It is, because I've seen, unfortunately, large amounts of duplicative development work because of fears of well, I don't know what's in there. And what extra burdens am I going to take on to double check what's in there once someone read that open source label? And I'd like to find a way to address some of those concerns, and wondering if jargon is a place to begin the discussion around, like, well, what do we need to make sure we discuss and make visible about the gatekeeping process that's involved when community development is part of the process, and what do we need to make sure we make clear about the reuse of software when we do make it available publicly. That might allow it to be adopted and reduce the duplicative effort.
And I think that question for a lot of us, I mean, it's the thing that keeps us up at night, because, all right, we'll take Pets. Petsy has a long history, but if every Petsy developer lost their job tomorrow, how long, for how long would Petsy be reliable software? So that's the thing. You can put a stamp on it, but that's a very temporary thing. And so I think that a way of rephrasing the question you asked is, what is the long-term future of the software that I'm now going to invest in? And the answer to that comes down to, is somebody going to keep funding the software developers and maintainers to do that? And that's something that keeps us up at night. And there are very optimistic outlooks on it, and there are very pessimistic outlooks on it. That's why we have a whole panel, I guess.
Yeah, and I'd say another thing, there's no lookup place where you can find out all the details about each group, but as Aaron said, they have NFM has a clear quality control process before your pull request is ever merged. With all of our packages, we don't allow someone to just hack lines of code and then we release it the next day. We test it like crazy. We make sure that it runs correctly. We try to break it, and we all look at it. And so there are certainly open source packages out there that don't have robust testing and pull request types of infrastructures. And so, I don't know if there's a clear way that we get a stamp of approval that we do these things right or not. But that might be a thing to look for as a user to see what, if you want to adopt a package, find out if they have some, quality control processes in place before you just start, downloading people's code. Right.
Yeah, I'd like to add that I think for MFEM, PETSC, a bunch of the other packages being talked about today, I think all of them have improved a lot in software quality over the past several years, just as we've gotten like much better about robust continuous integration kind of testing. Like I feel a lot more confident that when I check out a version of PETSC, something hasn't been broken because we have a pretty good and growing test suite. I don't want to get complacent, but I feel like it's a lot better than it was before we were able to do so much testing.
Yeah, the XSDK project is seeking to define some guidelines and recognize packages that have sort of met some minimum requirements towards some of these concerns, quality and contributor guides and all these other things.
Another thing that I find very useful when I'm going to grab a library and try and pull it into software that I'm working on, usually I'm worried about how well that software is going to be supported later. And sort of the best metric I've found for future success and future support is there a thriving community sitting under it right now? I can't guarantee that the community will be there in 10 years, but right now, at least is there discussion? Are there people? Are there pull requests happening? Is it still moving? Usually, like when projects sort of stop moving, that's sort of when they start dying off. So that can address some of the concerns for future stability of the software.
I mean, I would also say that a lot of our sort of customers are the national labs themselves. So we would be in big trouble if from one day to the next we just stop developing our software. People would not be happy with us. And sort of as a byproduct, I would say that the long-term stability of our software, while not guaranteed, I mean, nothing in life is safe, is fairly good. And if you look at how old our packages in general are, I mean, PETSC and Tolinos and all these packages, I mean, they're 20, some of them are longer than 20 years, like have a history of more than 20 years. I mean, that is pretty impressive for open source software packages.
Daniel, were you gonna say something? Sorry, I saw your thing pop up. So this is changing track a little bit. Christopher Subich, did I pronounce that correctly? Also submitted a question. Maybe he can unmute and ask that.
Let me find my microphone here. Okay. Since this is a really broad audience, I'll generalize the question a little bit. I'm working mostly with codes that have a long legacy background. Like a lot of the numerics inside would feel at home in a numerical recipes in Fortran book. At what point is it worth taking a look at these nice structured algorithms that ultimately look like applying a stencil to a matrix, applying a stencil to a grid, and saying, okay, transforming the problem into something appropriate for some of these numerical libraries. I mean, the very act of that transformation is, well, a lot of coding work, but also like politically in a legacy organization needs a lot of buy-in. So what is the best way to first see if it's worthwhile and second demonstrate it to people who might have to, who are going to be asked possibly to change the way they work?
I mean, a very quick comment on that. Generally for us, it's a new machine comes around and people cannot run on the old machine anymore. And at that point, something has to change, and that is just as good an occasion as any to actually start thinking about switching from legacy code or porting legacy code to new code. And I mean, it's a constant process. I mean, we have that going on all the time. Convincing people to do that on their own, however, I am not sure that that will ever happen. If people can use their software, they will always use the old software.
I don't know if that's 100% true. I'll find in a lot of scientific disciplines, there will be some code that's, 90% in Fortran 77. It's got all this old stuff. And they've been, cobbling it together, adding patches to add new features. A lot of it's out of numerical recipes, et cetera. But at some point, some other group comes out with a package that is higher order accurate. It's adaptive. It's faster. It's more scalable. It runs on GPUs. And suddenly your group is put to shame, and nobody wants your stuff anymore. And so sometimes it really is that kind of competition in the scientific community that gets some of these, old packages to finally get around to changing things. And maybe if they were forward thinking and they'd been looking ahead a little bit, they wouldn't have been surprised by the competition. But it happens, and things are developing fast now. Architectures are changing so fast that trying to get a small group of, say, grad students or postdocs to keep up with all of it at once and change everything in their codes is just not tenable anymore. And so, I think if you don't want to be left behind, somehow get comfortable with using libraries and find the right ones, but stick with them.
Yeah, I find that a lot of the new development in my group kind of comes out of new methods. People think up new ideas, and then people will prototype the new method, and then eventually it'll land in one of the big libraries because it's been shown to be useful in the problems we're trying to solve at the laboratories. So it usually is like both sort of new methods driven, but also like, there are these big problems. We're, like Lawrence Livermore is a very applied laboratory. We have real problems we're trying to solve. And if we can solve them better, we tend to do it.
I believe Samik posted a question in Zoom chat rather than Slack, but maybe you can unmute and ask that as well.
Hey, my name is Samik, and I just I think it was a question which was asked right off the bat about this move from like licensed software to open source, and I was like curious about how it disrupts the revenue model. So a bunch of people who were making money before, they don't make money anymore, and there are a new bunch of people who were not making money are making money. I mean, how does that kind of affect that entire sort of spectrum?
There's consulting and support, and I think that will continue. Yeah.
So it's also so our revenue model at the national laboratories is very different from the market, right? So we're paid to push the envelope to solve these problems, and we don't have to sell our software, right? So putting it out so other people can solve problems is just win for us, right? Especially if they can help bring back changes that help our code. Now, in terms of sort of disrupting the revenue model in general, the open source community has actually put a lot of thought into this, and software is kind of a kind of an ever expanding bubble of capabilities. You can only make money at the edge of that bubble when you're doing things that the open source community hasn't already figured out. And is not already free out there, right? And this has actually been true for a long time, right? So companies get in there and do something different to make money, but eventually open source folks say, oh, we could do that too, and write that software, and then the companies have to keep moving. So honestly, I think it keeps pushing the envelope globally.
Another example is there's a commercial software package being built on top of AMRX, And honestly, it's a win-win. So they're going to make money from the added value and from all of that support they're going to give the customer to make sure it runs on exactly their problems. But it would be silly for them to start from scratch. You know, it's open source. They're not stealing. We have a very collegial relationship. They're going to make money supporting customers using it in a very particular way. They give us really useful feedback. We're not paid by them, but it really is a mutually beneficial relationship. So I don't think it has to be an either or. But like I said, it'd be silly for them to start from scratch and reproduce what we've got. We're very happy for them to take it and run with it. I guess they're not interfering with our revenue stream because that's, again, national labs are a different funding model. But we can have a symbiotic relationship, I think.
I'd like to add, in addition to working with PETSC, I work on a PETSC-based application, P-Flowtran. It's a subsurface flow and reactive transport simulator. And it's been used quite a bit in industry, and there are actually a couple companies that are actually, you know, like offering basically P-Flowtran support and consulting and under a cloud infrastructure kind of model. Like they have a front end that lets you run your simulations that you need to do, you know, using cloud resources, and they help people. And, you know, that's a model that people are using to, you know, monetize some of the things that, you know, have gone into the completely open source P-Flowtran thing, which has a license that lets people do things like that. So that's another way that, you know, people can do this sort of thing.
I think one aspect of this is if you read the details of the BSD license that a lot of us use, it says that we don't guarantee anything about our software. I mean, our reputations try to guarantee that, but we will not make you a monetary guarantee that your wing will not rip off of the airplane. But there are these companies, and they'll work with our stuff. They'll build things off of our tools, and they'll put that guarantee on there, and that's what people often pay for. So I mean, Sundials is used in MATLAB, it's used in Mathematica, it's used, you know, in all kinds of packages that you have to pay for, and that they guarantee its accuracy. But, you know, and just like with him, we don't get any money from them, but it's nice to see that it's used and it's kind of pervasive. But I think a part of what people still pay for is that guarantee. They want to know who they can call when something breaks. And I'm not going to answer the phone if somebody else's code breaks because they're using my stuff incorrectly. And so we'll help them. We'll do, you know, email, chat and stuff, but we aren't going to, you know, fix it for them. I guess.
I just wanted to make a comment that maybe you guys can chime in about, is actually the complete sort of flip side of it, where this is particularly driven by machine learning these days, that there is cases of private, you know, for-profit entities open sourcing their code and their tools for what I presume is that, you know, they believe that the accelerated pace of development from open sourcing that is worth more than keeping that tool proprietary and private. And I think, you know, PyTorch is a good example of this, for instance, and sort of, you know, Facebook's involvement with that and the community developed around it. And, you know, over time, it has actually become more or less the premier machine learning library that we use in our scientific research. And so it's interesting to see that happen also somewhat in the opposite direction. We have, let me check. Yeah, we have one more question actually in Zoom. Julio, if you can unmute and ask.
Thank you. Yes, but I think that they already answered the question. My question was more on the license agreement and how you guys do with so much available things with open source. For example, when I was watching the presentation from Amrex, I was wondering, well, we see most of these things, for example, in SU2. Well, Fun3D also have very good feature as well in OpenFOAM. But I was still thinking, how can we have different resources, different things, and on top of that, we also have commercial packages that they have a huge market share. But like I also mentioned in my comment, most of them are decades old, and here we are seeing things that are really, really cutting edge. Possibly these things will be available in these commercial packages in 5 or 6 years, maybe, or sometimes earlier. But that was basically my comment / question. Thank you.
So with regards to commercial packages, they are definitely not a static target. They are definitely a moving target. They are constantly developing, and sometimes they actually do pull, some commercial packages are using some of these libraries to solve some of their problems. One thing the commercial packages provide, though, that we really don't is they provide a user experience, right? They package all this stuff up into a nice GUI. They've got a big support model, and they've done they do a really good job of integrating a lot of this stuff, even though some of their algorithms are a little bit behind. We're scientists. We're on the bleeding edge of the methods, and so we're putting these methods out into libraries. So yeah, I think some of this stuff will appear into your Fluents and star CCMs and those sorts of codes over time. It just I'm not so sure we're ever going to compete in the realm of packaging it all up and providing a good user experience. That's not really what we do.
Right. It's also the case that folks come to us when, for example, OpenFOAM doesn't allow them to do what they want to do. So for the things it does, where they can have, I like that phrase, the user experience. And we're fine with that. We have the flexibility, the agility to do a larger range of things. And so, let's say they want to explore algorithm space, and they have exactly 3 options in OpenFOAM, but they can explore it in like an AMRX based or other based code. So we tend to get the people who have perhaps tried. Well, we have junior developers who don't want to go commercial, but we also have people who've tried the commercial. It doesn't meet their needs. And they come and say, okay, is there something else out there so that they don't have to start from scratch? But again, we want to be cutting edge, right? We are on the machines as soon as they come out, and the commercial products can't sell something that works on those new machines because there isn't enough. Those machines haven't existed enough yet. So I think you'll find that like the packages here are on GPUs before a lot of the commercial packages are, for example.
We also tend to scale bigger because we have
Right.
access to bigger machines.
Yeah. Another thing, I don't know. I'm very curious how the future will look like in this regards. I'm seeing that with ATPESC and many other HPC training sessions. I've seen that there are more and more people gaining these experience and knowledge and all of that. And now sometimes I think, well, maybe 20 years down the road, there will be so many people trained with the right capabilities that, well, maybe this type of tool will be more, they will be available or maybe ready for commercial applications as long as the license agreement match with companies and all these federal labs. But I'm very eager to see how the future will look like in these regards, because, for example, I remember when I started in CFD, like, I don't know, 10 years ago, very few people knew about, for example, OpenFOAM. I remember, for example, when to do something simple with a mesh, you had to use Gambit, and nowadays things are very quick, and now people are gaining the experience and the training and the exposure of these type of things. Now, before accessing an HPC system was very complicated. Now you can use British short proposal and at XCity, for example, and you get 1,000 of computing hours. Now a small research group can write proposals and grants they get grants to run their research on these big machines. So I think the future is definitely interesting, and how things are changing extremely fast, extremely fast. And my point of view, or my idea, is that it will be a point where just keeping up will be just almost impossible. I think that was mentioned by Daniel and Reynolds, Mr. Reynolds. He mentioned that. I think that there will be a point where you cannot just catch up. It's just basically learn new things and just go with it, because you won't be able to really deliver when you have, for example, all these people, very, very smart people doing things that are like years ahead of what we see already. Thank you very much.
Well, just to kind of elaborate on that a little bit, I wasn't saying that you couldn't contribute. What I really am saying is you don't want to start from scratch. And
I agree.
Just like Aaron was saying, you know, the development is at the cutting edge. And if you try to build up from ground zero all the way up to the cutting edge, you're going to be coding blahs, you know, and you know, QR factors. And you're just be doing way too much redundant stuff by yourself. But if you build off of something that's there, you're going to get to that cutting edge a lot more quickly. And you'll be able to start doing your contributions without having to recode everything and test everything and make sure it all works in every possible case. So I was trying to dissuade people not from the profession. I was trying to dissuade people from writing everything from scratch. And that was my point.
Yeah, absolutely. Yeah.
But I mean, that is a natural process, right? I mean, nowadays, nobody is coding their own communication layer anymore. We're all using MPI. We rely that somebody did it correctly. And the same will happen for these packages.
Actually, speaking of dependencies, this is a good point to bring up. Miriam had a question that I thought was good. Maybe she can unmute and.
Yeah, hi. I was wondering about best practices with regard to third-party dependencies. The code that I contribute to a lot, they never want to include new dependencies if they can avoid it, because that makes it harder on the user. On the other hand, it saves you a lot of extra coding. What do you think?
I would say as long as they're optional dependencies, you're in a safe place. You know, like you said, it kind of discourages people when they can't bring in a library that solves some problem they have. So yeah, I think you got to stay open about it.
I will say that we're all benefiting from this one project called SPAC, and they're making it easy to install all of our stuff like it's, you know, the trivialest thing in the world on all kinds of architectures. And we have to work with them, et cetera, but it's making that bar a lot smaller for lots of people. So, you know, if you depend on the SPAC dependency and you can set that up appropriately, then, you know, 9 times out of 10 that'll work correctly, unless you're on a brand new machine or a brand new compiler or CLang on Mac or something. But it can be it definitely helps, I think.
I would say that easy is aspirational at this point, but I think
okay.
You're not going to completely disagree. So I think what you're saying is an issue for a lot of people, and everyone in the software community acknowledges it. And I think there is, you know, the years we've been doing this, there has been visible progress towards making that easier. Because yes, it is the worst thing. You get onto a new system and you're trying to load the versions, and the system has certain versions installed, but you need a different version because these aren't compatible. And, you know, interoperability is a expletive deleted. But there is visible progress towards it. I think everyone understands that we've got to get there, because we lose so much time with the incompatible versions, and, you know, they upgrade the compiler on the machine, but this library didn't get upgraded. And if you're dependent on that, you're dead in the water. And that's the thing that scares us all about dependencies, is being dead in the water because of something out of your control. So I think in some sense, we're all doing the best we can by, for example, you know, AMRX can build with Hyper or it can build without Hyper. You know, we try and leave that to the user's choice. We try and give them as many options so that they don't get stuck. But then there are points where if you don't depend on something, you're kind of stuck. I think we've made, I mean, I'm optimistic about this. We've made visible progress, the SPAC system and the XSD case, and the public support for interoperability being important. I think the culture has also changed. People kind of realize we've got to do this. And, you know, how many days have you wasted trying to get versions to play with each other? We've all been there, and it sucks.
Yeah, the XSDK project in particular has spent a lot of time focusing on at least getting sort of the libraries that you're seeing today and the libraries that are in the XSDK package to work together at particular version numbers and make that a lot easier. I agree, though. It can be really hard, and it's a tough decision whether to you know, try to roll it yourself or depend on an external package. You know, when I try and work through those decisions, there's a couple things that I look at. One of them is, you know, is this package I'm going to be depending on well supported, right? Is it am I going to be able to get help if I need to? The other thing I look at is this thing that I'm adding something that I'm pretty expert at, or is it something that's pretty far away from my core competence? If it's pretty far away from my core competence and my team's core competence, it's probably a bit much to ask them to re-roll. We'll get something pretty suboptimal if we roll it ourselves. So, you know, those are the things you got to balance when you run these big software projects that put a ton of code together. And we've got some really big ones at the laboratory. It's things with, like, you know, hundreds of dependencies and people whose full-time job is to manage that. So it is a real task. I agree.
I think one of the things we are seeing too, the testing infrastructure. I mean, a lot of us have been asking for this and it's starting to happen. So, you know, if we want our codes, you know, we make some change in AMRX, we want it to work on all the systems people are running it on. So we can run our regression tests locally, but we want to run them on all these different systems. Well, that's hard. Is it going to take one member of the team having to log in, run it here, log in, run it there? So this testing infrastructure is essential. We don't always see the incompatibilities that might be there. The facilities, so the supercomputer centers are really acknowledging that and trying to be part of the solution and saying, okay, we'll make it easier for you to test it so that by the time the user wants to use it, it works. But it's very much a work in progress. So a couple of years, hopefully.
Richard, maybe you probably have longer experience with this than I do, but one of the things with this dependency issue is there have been times when I have installed PETC just to get PETC to install something else. And I've always thought that the build system has sort of gone above and beyond a little bit to include these, like, you know, -- download package, and there's a whole lot of them at this point. And like I said, it's been easy enough that I've installed PETC just to get third-party packages done for me. I mean, Richard, you've been around way longer than I have. I guess you know more about the evolution of that, but I think.
Yeah, I mean, it sort of, you know, it started in response to, you know, what the original question brought up, right? It was just, you know, as people wanted PETC to do more and more things, right? You get to this point of, you know, hey, am I going to be able to do a good job writing this, or should I really, you know, use what somebody else wrote and I know they can do a good job? And also, there's the other question of, you know, maybe I can do an okay job writing this thing, but am I going to really have time to maintain this, right? Whereas, you know, some dedicated package that I know has solid maintainers, I'm going to want to use that. So as more and more things get, you know, people wanted to use more and more packages from PETC, and there wasn't anything like SPAC that existed. You know, mostly Matt Nepoli wrote this thing called the build system that basically it actually constructs you know, a dependency graph and of all the packages you want to try to use, and tries to build them all in a nice way. And pretty much almost every package that PETC can use optionally, you can just ask PETC to download and configure and build that package. And yes, I do know a lot of people who have installed PETC just to get it to build the packages, because the automated build system would do it, whereas when they tried to do it manually, they would run into some kind of problem. And I'm pleased to see that something like SPAC exists, and I hope that the problem with build system was we tried a couple times to get some other projects to use it other than PETSI, but it really just sort of stubbornly it just remained a very PETSI centric thing, and we need something like what build system does that works for a larger ecosystem.
Yeah, and with that, we're actually out of time. Thank you to our panelists for participating in this. And what's coming up next is actually 3 minutes from now. Parallel session 3 is starting, and the subject matter experts selections are due during the break right after that. So hope to see you guys in those sessions.
Thank you.
Thanks all.